Good day, everyone. Today we're going to look at two-dimensional motion, or as it's known as angled motion. So we're putting the X and Y components together. Now, if you recognize this slide, right, it says by the end of the lesson you should be able to express motion as a narrative, mathematical, and graphical representation. So we're just continuing on with the same idea, but we're specifically looking at angled motion. All right, so what we're going to look at is taking an angle, a velocity at an angle, separating it out into its horizontal and vertical components, and deriving all the useful information such as time, acceleration, initial, final velocities, and such forth in both the horizontal and vertical directions. So let's get started. So we're going to do a lot of right triangles. So the Pythagorean theorem, sine of theta is going to be the opposite over the hypotenuse. The cosine is the adjacent over hypotenuse, and tangent of theta is opposite over adjacent. All right, so make sure you know how to use these equations. They should be pretty straightforward to memorize, and you should have some practice with them already. Make sure that your calculator is in degrees, so please make sure it's in degrees. So just quick check, if you do sine of 30 should equal 0.5. If not, you are in radians, and you need to use your mode function to change from radians into degrees, because physics we use degrees. Alright, so here we go. I'm not going to do every one of these for you, just a quick, simple practice of what's going on. But here we have an opposite of my theta, my unknown angle, over my hypotenuse, and so I'm simply going to be using sine, actually, specifically. Alright, I'm going to use the inverse of my sine, because I don't know theta, so if you do second sine, you'll get your inverse, and that allows you to do 2 over the hypotenuse of 8, giving you 14.5 degrees. Alright, so that's pretty straightforward, pretty easy. We're going to come over here and do tangent. I'm just going to kind of do a quick little leap. If you know that these sides are congruent, that means it's isosceles triangles. So that means that the inside angles, the size of 90, is going to be 45 degrees. So it's a quick, easy check of what that angle is if you know that these two edges are similar, or they're equal. So we'll come over here and do this one so you can see the inverse tangent work. So inverse tangent is -1, and then you're going to have the opposite, which is going to be 3 meters divided by 4 meters, giving you the angle of 36.9 degrees. I'll let you do some of these, but you can see how they work. But this is going to be, I know my theta, all right, I know my theta, I know my hypotenuse, so I can just figure out what my components are. I want to do this one specifically because this is where most of your physics problems are going to be in. Your hypotenuse here will be your velocity, or initial velocity, and so I want to help you kind of figure out how to work those. And so you would use, for the say the y component here in the vertical, you would use sine. For the y component here, you would use sine, right, of my 37 degrees equals, I'm going to just use y because I don't know it, and it's in the y direction, of 10 meters. So you multiply by 10 meters over, canceling that out, multiplying by 10 meters here. So what I have is the sine of 37 degrees times 10 gives me my y, right? And the y here would be 7.98, so we're just going to round up for simplicity for right now, just say 8 meters. Now in the x direction, because it's adjacent, I'm going to have to use cosine. So that equation would be cosine of 37 degrees equals the opposite, so I'm going to use x here because it's an x component, of 10, and you can see that we're going to have to multiply by 10 again to get rid of it. So you can see there's some simplicity when you're looking at the sine and cosine, that you can almost do the same thing, but really what you're changing is the sine and cosine if you know your theta. So it kind of helps out in the long run going through things. And so just to speed things along, so x would be 6 meters. It would be 6.018, and so that would just kind of round up to 6. So for simplicity for now, we'll just use 6 meters. All right. It's displacement at an angle. So sometimes they'll give you a problem like this in which you have to find, and you see that the displacement is going to be this, and I apologize, that's not a straight line, but that is the displacement that you're looking for. Now, you can see very quickly what we're going to be doing is you're going to figure out, all the y components, allow you to figure out the x components. Okay, and so you can see the y, again, adding your vectors. So 4 plus 3 plus 8 is 15 meters. Over here for your y, you're going to have 3 up minus 1 down plus 7 equals 9 meters. Alright, and so I can use the Pythagorean theorem. So 15 squared plus 9 squared is going to be 17.49, so we'll round it to 5. Okay, now we need to find theta, and now that I know the hypotenuse, I can use sine, cosine, tangent. However, because this is a rounded number, your theta here is going to be just a little off, and so I prefer, because I know that these are exact numbers, exact measurements, I'm going to use tangent. So I'll use the inverse of tangent, okay, which is the opposite over adjacent. So 9 divided by 15, giving me the angle of 31 degrees. Okay, it's actually 30.94, so it rounds up again for simplicity of just getting the concept. So velocity at angle, just kind of give you some uses, just kind of summarize what we're doing. All right, so we've practiced our trigonometry. We've kind of explored displacement, but really the velocity is where we're going to stay with physics. We're really not going to go back to displacement, but it just kind of gives a good practice of how to use trigonometry to find out good information. But the initial velocity, right, it'll help us figure out time spent in the air. So it's really key here that if we know that if we have our initial velocity at angle, we can find the y components to find out the time, or the x component, again, because time is continuous, and if I'm looking at this initial velocity inside an angle, I'm actually going to have a motion that we call, in algebra 2, a parabola. So it's going to be something like that. Okay, and so using this information, I can figure out the time is going to be the same up and down as it would be in total of the x direction. So that's really good information to remember, that if I'm looking for the total flight time of an object, that I can't actually find the horizontal time or the total time it's spent in the air will help me figure that out. So that's awesome information and quick, easy information to remember. A soccer ball at rest on the ground is kicked with an initial velocity of 20 meters per second at a launch angle of 35 degrees. Calculate the total flight time, assuming the air resistance is negligible. So I went ahead and pre-drew out our problem here. I have a soccer ball, initial velocity. The 35 degrees, however, is to the x-axis, all right? So launch angle, which makes sense because I want to kick a ball off the ground, not out of a 90-degree y direction, so that makes a lot more sense. All right, so let's get started, shall we? Fill in the information that I know. I know that the initial position, I'm going to give it 0. The initial position in the y direction will be 0, and the final position in the y direction will be 0 as well. All right, I know that the acceleration in the y direction, is negative 9.81 in both the up and down. I know that the final velocity up is going to be 0, and the final, which makes the initial down 0 in the y direction. I don't know the final position or the initial for the y. I don't know the final position for the x. I can calculate the initial position, the initial velocity of both the y and the x. So let's go ahead and do that real quick. Alright, so we have found the initial velocity in both the x and y direction, the x being 16.4 meters per second and the y being 11.5 meters per second. Now, because I see that the initial position is 0 and the final position is 0, I do remember from the last lesson that the initial position and the final position are equal, but opposite, so that makes it 11.5. Alright, so if I'm going to calculate the total flight time, I can find the y time or the x time, and we'll get to the same answer. So since I have more y, let's do the time for each of the up and down. time at 1.17 seconds. So I now found the time in the X up, or excuse me, the Y up and the Y down. So the total flight time would be the addition of those two. So here, time total would be the addition, giving me 2.34 seconds. All right, and so that gives me a flight time. I've answered the question. Now, however, I can, in some regards, because I know that it ends and stops in the same position, I can actually combine the Y together, and I can do that real quick. There you go.